Okay, so I'm gonna show you another way to do trig substitution. So first let's derive some identities. Okay, so we know that sine squared plus cosine squared equals 1. Then we can actually rewrite this into this. Okay, that's our first identity that we're gonna use. Then what else? Okay, so notice how you can rewrite this identity into this. So we actually don't use this identity, and I'm not gonna show you why right now because I want to make this a quick video. But basically it makes our answer negative, and we don't like that, so we don't use this identity. So we just stick with this one. Okay, now we have two more identities. So let's see what those are. Well, if I divide this identity by let's see, by cosine squared, well, this is what happens. Sine squared over cosine squared, that's tangent squared. Cosine squared over cosine squared, that's 1. And then 1 over cosine squared, that's secant. That's secant squared. Okay, now so we have this identity in which cosine squared is on this side. We have another identity in which secant squared is on this side, and we can, okay, let's rewrite this. So then we would have let's see, okay, now notice that I could have divided this by sine squared theta, and I would have gotten this. Oops. So I would have gotten this identity, but the reason we don't use this one, and also notice that I can rewrite this into right, so like these two are similar to these ones over here, but the reason we're also not gonna use these two, it's because of it's the same reason. They're gonna give us a negative answer, and you can check that with the method I'm gonna show you right now. So let's see. So let's suppose we want to integrate 4 minus x squared dx. You were given some rules about how to make a trig substitution. Sorry, this is supposed to have a square root. Okay, so if you ask me personally, I don't know them. I don't know what, I don't use those rules when I use trig substitution. So what I do instead is the following. And this is a really easy example, but this method actually works for any integral that requires trig substitution. So let's see. So I factor out the 4. So basically I make it look like this, in which I have a 1. Okay, so that's what I'm gonna do. You're gonna see. So I factored out the 4. Okay, and so then I can rewrite this into this. Oops, you cannot see, sorry. Okay, and this is a 2 instead. I just wanted to see that, right? I had this, I turned it into this, and then the square root of 4, that's 2. So then this integral right here, it's gonna be 2 okay, and let's see which identity is similar has this form. So if I look at this one, right, we have a 1 minus something squared, and that something is sine. So I can say, okay, well, sine, let's let the sine theta equal x over 2. Do you see what I did there? It's just I got it into one of these forms, and then I said, okay, now let's replace by sine. Okay, so then if I do that, I'm gonna get 1 minus sine squared, right, because we said sine theta equals x over 2. But now we can have it at the x over here, we need to turn it into a d theta. So this is basically just U substitution right now. So let's see, if I differentiate this equation, well, actually let me just, oops. So I just multiply that 2. So I get 2 sine theta equals x. Now let's actually differentiate this with respect to x. So this is going to be 2 cosine theta d theta equal 1 dx. So just dx. And so that implies that our dx, right, what we had over here, it's actually going to be this expression. 2 cosine theta d theta. And so yeah, you can, and so then you can solve this. So then 1 minus sine squared, that's going to turn into a cosine squared. Then the square root of that, that's going to be a cosine. Oh, and actually, so 2 times 2, that's 4. D theta, don't forget. Okay, and then from here, we can use our identity, let's see. So cosine squared theta equals 1 plus cosine 2 theta over 2. Okay, and I'm not gonna prove this to you, but this is true. If you want to know why, you know, like, yeah, just let me know, and I can make a quick video showing you this proof, how to derive this equation, this identity. Okay, now we have so then I divide by 4 over 2, so then I get to my integral is just gonna be this. And then that's anti-differentiated, so let's take the integral of this. So that's gonna be sine, that turns into cosine, and wait. And don't forget your, oh sorry, I forgot my plus c. Plus c. Okay, so now we're gonna have 2 theta plus sine 2 theta plus c. And so then we actually don't want to have our answer in theta because they gave us the integral in x's, right? We used x's, so we have to turn this into x's also. And I'm gonna use this fact over here. Sine theta equals x over 2. So then if I draw a triangle, so let me do that over here. So here's my theta, and the sine of this theta is gonna have to be x over 2. So then if we want to find this side, I'm gonna name it a. Well, we know a relationship that says a squared plus x squared equals 4, 2 squares, which is 4. So then we have that a is 4 minus x squared. So this side is going to be 4 minus x squared. And so to theta, well, theta, remember that you can say that the tangent of theta, that's x over root of 4 minus x squared. So then if you want to solve for theta, what you do is you take the inverse of that. So theta is going to equal inverse tangent of all of this. Okay, and then let's see, what can we do here? We can actually rewrite this into, because we have theta, so we don't have 2 theta, but there's also an identity that says that sine 2 theta, it's equivalent to 2 sine theta cosine theta. So I know this is a little gross, but let me just do it. Okay. So then sine theta, well, sine theta is x over 2. So I'm gonna rewrite all of this in this on this paper. So we're gonna have 2 arctangent okay, arctangent of all of this, that's my theta. And then sine theta, it's x over 2, so I'm gonna have plus x over 2, and then my cosine theta, that's this over this. And then don't forget your plus c. And so my answer is gonna be plus let's see. Oh, that's 4. Sorry. 4 minus x squared over 4. And so yeah, that's my answer. Oh wait, sorry, I forgot about this 2. So I actually have a 2 over here, 2 times sine theta times cosine theta. So then this is actually 2 over here. Okay, sorry about that. So this is how I personally do trig substitutions, because I cannot memorize the rules. But if you can memorize the rules, then you can do that. But I personally find this to be a more intuitive process. By turning my equation into one of these forms, and then getting this, and then saying, okay, which identity does this match? And in this case, it matched this one. So then I said, okay, sine theta equals x over 2. And from there, you can solve your integral like you would do if you just memorized the rules. Okay, so that's gonna be my take on this. And also, okay, so notice that here I wrote arctangent. You can also do like arccosine or arcsine. So if I used arcsine, for example, my theta would have been let's see, my theta would have been arc sine x over 2. So then instead of this, instead of arc tan all of this, I could have written 2 arc sine x over 2. That's also something you can do. Okay, yeah, I'm just gonna end right here.